Next week, Danish astronaut Andreas Mogenson is scheduled for a first-of-its-kind experiment operation during his week-long visit to the International Space Station. This experiment is called Interact, and in it, he will be operating a rover on the Earth from inside the International Space Station with controls that will give him tactile force feedback as the robot encounters resistance. This experiment is a product of the European Space Agency's Telerobotics and Haptics Lab in the Netherlands, and joining us today is the principal investigator for that, Dr. Andre Schiele. Joining us this morning, Dr. Andre Schiele, how are you doing today?
Thanks, I'm very fine.
You had a precursor to this experiment previously on the International Space Station. What were you able to learn from the first version of this experiment?
That is correct. In June this year, we actually performed the first network connectivity test between our force reflective joystick on the space station and another force reflective joystick that we had here on ground in Noordwijk at the laboratories in ESA. And we tested out the delay and the bandwidth and the signal quality that we can achieve by sending these bilateral control signals between space and ground through the TETRIS KU forward link. So signals travel about 90,000 kilometers, and we didn't know exactly how much delay it would give, because for the robotic controls, that's an essential metric to know. So we performed a remote handshake, which was a visual test that we did with Terry Wirtz and Kimia Yui in June and August. And we are now ready. We know about the properties of this link, and we are now ready to move on to the next bigger step to actually control a full robotic system next week.
So next week, Mogenson will be using the Centaur from inside the International Space Station. Can you describe that hardware for us and its design?
Right. Centaur is actually a new robot that we designed. It's a 500 to 600 kilogram class rover. It has 4 wheels. It can drive and steer as any normal vehicle. Actually, it's a pretty fast robot. So we decided to make something that's fast and that can operate at human scale type of speeds. It has 2 arms that are 7 degrees of freedom each, like your human arms. So they can reach out to objects, to the ground. They can reach up. They can manipulate together with humans. And the robot arms are very specific because they are very force sensitive. They can be controlled in compliance control, which means they can render any stiffness damping that we program it to. And this way, Interact Centaur can interact with stiff objects, and it can assemble mechanical facilities or do complex tasks that require force control. So it looks a bit like Wall-E, online media wrote, but other media wrote they compared it with number 5. So I'm not sure which robot that is famous looks closest to it.
So tell me about the experiment. Where will the Centaur be? What will Mogenson have it do? And how will you determine whether it was a success or not?
So Mogenson will be in the Columbus module on the International Space Station. He will use our Haptics One joystick and a tablet PC. That's all he has to control that robotic system on the surface. The robot itself has many, many degrees of freedom, about 30 degrees of freedom. So we designed specific graphical user interfaces for him. Now, the task that he has to complete is actually a sub-millimeter position task where he has to actually mate a connector into a socket with a tolerance of only 150 micrometers. In order to do that, he first needs to scan around the environment here in Noordwijk. We have an indoor environment where the robot is located. So we're independent from the weather condition, which is known not always to be optimal in the Netherlands. And he needs to scan the indoor environment to look for a taskboard. After that, he has to use the tablet PC to actually real-time control that robot to drive towards that taskboard and park in front of that taskboard at a suitable location. For this, he will be using augmented reality that we implemented in the video stream in order to hint him at ideal locations for that robot for arm manipulability afterwards. So once he parked, he will need to control the robotic arm via the tablet PC and the joystick to actually insert that pack into the hole or the connector into its socket.
Dr. Schiele, so what are the future space technology applications, and also what are some of the Earth applications we could see from this experiment?
Well, in space, much talk has happened about combined human robotic exploration in the future. And ideas have been brought out for humans to go back to Mars or to Moon or perhaps to an asteroid. What we decided at ESA is to actually prepare generic technologies that would allow a somewhat different mission scenario. In our case, we promote humans being in orbiting stations around planets. So, for example, if you take Mars, it is currently impossible to send humans to the surface of Mars. But it would be perhaps quite possible to actually send humans to an orbit around Mars and have robotics located on the Martian surface to do human-like tasks. So Interact will demonstrate, in fact, technologies, how human presence can be projected into those robotic systems that are on planetary surfaces without requiring humans to be there. And applications can be multiple, ranging from setting up telescope facilities, for example, on the lunar surface, on the far side of the moon, or extracting minerals and doing geophysical research on Mars or other bodies. So there are multiple application cases. We could actually invert the scenario as well and have humans on the surface control robotics with this technology in the space environment. If we're thinking about satellite servicing or debris removal, where intuitive controlled robots could catch satellites and tow them to different locations. And on Earth, the applications are similar. So in any places, basically, where humans cannot go, for example, in the deep sea, if you think of Deepwater Horizon, robotics was heavily used to actually fix the problem of the oil spill. So with the technology we are showing, this would be probably a bit more efficient and more intuitive. Or Fukushima as another example, as a disaster site where these robotic systems could intervene.
Well, Dr. Schiele, we appreciate you so much for joining us this morning and telling us all about the Interact experiment going on board the station.